This video is going to cover the topic of reflecting points on a coordinate graph. Be sure the date and topic are at the top of your page. The essential question for this video will be, how do we reflect a point across the x or y axis? We've probably thought of reflecting before, but perhaps not in math. I know that the first thing that comes to mind for me when I think about reflections is a mirror. If I look in a mirror, I see my reflection. It reflects what I look like back at me. On a coordinate graph, the x-axis can serve as a mirror to reflect a point. The y-axis can also be a mirror. Let's go ahead and make a quick coordinate graph here with all four quadrants, and let's plot a point, and we'll see how that would be reflected. So let's plot the point -5, 3. That should be right here, -5, 3. If I want to reflect this across the y-axis, that means that this y-axis, I'm going to just shade it darker as I talk about it, this y-axis is going to serve as our mirror. So the point that we have here, -5, 3, should be in the same place, just on the other or opposite side of the y-axis. So instead of this point being 5 points, 1, 2, 3, 4, 5 points to the left of the axis, it's going to be 5 points to the right. And it will land right here. Notice that the height of the point, the y value, did not change. I went from -5, 3 to a +5, 3, and these points are now on the opposite side of the y-axis because it has been reflected across the y-axis. Let's look at another example, this time reflecting across the x-axis. This time we'll plot the point -4, 3 right here. So we have -4, 3. And this time we want to see what happens if we reflect across the x-axis. That means that our x-axis this time is going to serve as our mirror. So again, this point will end up in the same place, just on the opposite side of the x-axis. So it's going to be, instead of going up 1, 2, 3 places above the x-axis, it needs to go 1, 2, 3 places below the x-axis. So it'll end up at -4, -3. And I notice here that the x-axis, the x-coordinate has remained the same, just the y-coordinate has changed, and the y-coordinates are opposites. Let's go ahead and summarize some of that information for our notes. First, let's take a look at reflecting over the y-axis. When the y-axis is our mirror, the value of the y-coordinate stays the same. However, on the other hand, the value of the x-coordinate becomes the opposite. We saw this with our example on the previous page, which was that -5, 3 became 5, 3. The x value changed from -5 to its opposite of 5, and our y value remained 3. Let's look at it again now as we reflect over the x-axis. When we reflect over the x-axis serves as our mirror. The value of the x-coordinate stays the same. On the other hand, the value of the y-coordinate will become the opposite. And again, as you can see right above here, in this example, when we reflected over the x-axis, we had -4, 3, and it became -4, +3. Right? The -4, the x-coordinate value, stayed the same, but a 3, became, that should say -3. It became its opposite. Let's do another couple examples just like that. Let's start by plotting the point 5, 4. So that's going to be in my first quadrant, 5, 4. And take a moment, let me write 5, 4 here, take a moment and think about where that would be if we reflect this over the y-axis. I remember that if I'm reflecting over the y-axis, right, that's this one, this would be my mirror, I'm going to use the same y value, but the opposite x value. So instead of going to the right 5, I'm going to go to the left 5, but still go up 4. So my point would be at negative 5, 4. So I'm going to go ahead and write that. Let's do another one. Let's plot the point 3, 2, and then let's reflect that over the x-axis. So my x value will stay the same. It's still 3 over to the right, but instead of going up 2, we would go down 2, right? Oh, and I forgot to mark these. So 3, 2 was our original, and now it's 3, negative 2. I'm going to write that here as well. 3, negative 2 when we've reflected it across the x-axis. To make sure we really understand reflecting coordinate values, sometimes we look at it without any numbers. So I have substituted the letters A and B to represent some coordinate. We'll go ahead and put this in quadrant 2. If I wanted to graph in red this thing that says negative AB, this is telling me that I want the opposite of A. So if I remember what I know about opposites, I know that if I start at 0, which is on my x, right, I would go 1, 2, 3, 4 to the left. So the opposite would go 1, 2, 3, 4 to the right. The B hasn't changed. So this would be where I would graph the opposite of A and B, right? So sometimes that negative is telling us the term opposite. I've substituted numbers again for letters, this time CD, and let's just go ahead and imagine CD is here, again, randomly in the second quadrant. I'm just kind of picking randomly here. And this time I want to do the opposite. I want C and the opposite of D. So starting at the origin, at the center, C doesn't change, so I'm still going to go to the same distance here. But my D is opposite. So instead of going up 2, I'm going to go down 2, or however the distance is, right? We're imagining we don't have numbers here. So this would be where I would have C and the opposite of D. And I know that's sort of abstract, but I just want to point out that we are looking at opposites when we are reflecting across either the X or Y axis. We even can practice kind of using the opposite of both. So again, I pick some letters GH to represent this spot here in the fourth quadrant. If I want the opposite of G and the opposite of H, right, then I would say, well, G was going to the right this many spaces, so the opposite would be to go to the left that many spaces, and H told us to go down, but now the opposite of H would have us go up. So this would be what we would call the opposite of G and the opposite of H. For your turn, I'll just have you plot one point. So I have the point negative 3, negative 2, and I'd like you to mark and record where the point would go if you reflect it over the x-axis. Knowing, of course, that our essential question was how do we reflect over the x and y axis? We'll practice with this in class. Be sure you bring any questions you might have as well.